Welcome to the Let's Answer Organic Chemistry series, Part 2 for IUPAC Nomenclature. In this video, we'll be tackling examples containing alkenes, alkynes, and enynes, as well as the stereochemical designations for alkenes. Without further ado, let's get started. What is the IUPAC name of the following compound? This is another class of compound known as an alkene. And alkenes have a hydrocarbon base where you have double bonds present on the chain. It's named similarly to alkanes, so because this parent chain has 10 carbons, we'll name this as a decene. The dec prefix referencing the 10 carbons and ene referencing the fact that it is an alkene. For alkenes, we have to specify where the double bond is. According to the numbering system we put in here, this has a 3 locant. The double bond is described by the 3 and 4 numbers. We choose the lower number 3. So the parent chain is 3 decene or decene. This can also be written as dec 3 ene, which is preferred by the IUPAC because the number 3 is directly beside the group that it is describing. We have to make sure that the double bond receives the lowest possible locant. So it doesn't matter where this methyl group is, we have to make sure that the double bond gets the lowest possible locant, which is why we numbered it from right to left rather than from left to right. If we numbered it from left to right, then this double bond would get a 7 locant, which is not preferred. So for the substituent is a methyl group. So it is a 2-methyl group. Therefore, this compound is named as 2-methyl 3-decene. This is a little bit more pronounceable than 2-methyl dec 3-ene, which is the preferred IUPAC name. But for chemists, they probably would use the first one because it's easier to say. Now, another feature of double bonds is that they exhibit stereoisomerism. And this is according again to the CIP rules or Cahn-Ingold-Prelog Rules. They are designated as either E or Z. Now, how do we know if this double bond is an E or Z configuration? This double bond only has 2 groups across the double bond. So it has this group and this group that are on opposite sides of the double bond. Because these groups are on opposite sides, so they're not arranged on the same side, they are arranged on opposite sides, this alkene has an E configuration. So we designate where the double bond is and what is its configuration and append it to the name to give you the complete IUPAC name, including the stereochemical descriptor, 3E. In common nomenclature, this is also known as a transalkene. So in common naming, we append the name trans to the name to indicate that this double bond has this kind of arrangement where the groups are on opposite sides. But this is usually applicable for simple alkenes where you have a hydrogen on each of the sides of the double bond. When you have more complicated alkenes with 4 substituents, this alkene has 2 substituents. If it had 3 or 4 substituents, then we would almost always use the easy notation. But in this case, either name is acceptable. But once again, the E is the preferred IUPAC system. If the double bond were arranged this way, then this would be a Z configuration or a cis configuration, because the alkyl groups are arranged on the same side of this double bond. So always remember to be aware of the stereochemistry about the double bond and to indicate its configuration, similar to the RS configuration in alkanes. In this next example, we have an alkene with two double bonds. We call this compound class as a diene. It's a special kind of alkene with double bonds, or two double bonds, which is why we have the word or the prefix di to indicate that there are two double bonds. We can also just name this as an alkene. This is a 6-carbon diene, so this is a hex prefix, and we name this as a hexadiene. Okay, if this were a simple alkene with only one double bond, this would be hexene. But because this is this has two double bonds, we name this as a diene, and we write the letter A here to make it easier to say. So rather than saying hexadiene, this is hexadiene. This is typically the case when you have a prefix that ends in a consonant and a parent chain suffix that starts with a consonant as well. So next we have to indicate the locants on the diene, or the two double bonds. And we have to make sure once again that they get the lowest possible locant. So we number it this way, where they get a 1 and a 3 locant. As for the bromo substituents, we have 5 bromo and 6 bromo. And so to assemble the name, this would be 5,6 dibromo, 1,3 hexadiene. Or preferably this would be written as 5,6 dibromo, hexa 1,3 diene. Now let's check for stereoisomers. This double bond has two hydrogens on the end of this double bond, and so it does not exhibit stereoisomerism. Whereas this double bond is disubstituted, one on either side of the alkene, and therefore there are two ways to arrange it, either in the E or the Z configuration. So once again, since the groups are on opposite ends of this double bond, this is an E alkene. So we write the name E, and this is referring to the second double bond. So this is 3E, 5,6 dibromo 1,3 hexadiene. Because this is also a disubstituted alkene, we can just write trans. And this is the complete name of this compound. For this example, we have a new functional group. Now this ring is called the benzene ring, and it is attached to this alkene linear chain. In IUPAC nomenclature, we typically name this with the benzene as the parent chain because it has precedence over the alkene. It has a higher priority because it is a ring rather than a straight chain, and it also contains double bonds. However, it is still common practice to name the alkene as the parent chain because it creates a much simpler name. It has more substituents, has the methyls jutting out from the linear chain, and the benzene ring, we name that as a substituent known as a phenyl substituent or phenyl group. So for this example, we'll name it as an alkene. The parent chain has 6 carbons. Therefore, this is an hexene with a double bond having a 2 locant. So we prioritize the double bond having the lowest possible locant. In that case, we number the chain from left to right. The substituents will have, so the methyl groups, there are 2 of them, and one of them has a 2, one of them has a 3. And we have this benzene ring attached, that's a phenyl group, with a 1 locant. So the name of this compound, arranging by alphabetical order, is 2,3-dimethyl 1-phenyl hex-2-ene. Hex-2-ene is preferred over 2-hexene, but you can also use 2-hexene. Then let's check for stereoisomerism. So on either side of this double bond, there are 2 different groups. To assign its E or Z configuration, we have to determine which of these 2 groups on either side has the higher priority. We'll use the Cahn-Ingold-Prelog system to determine which one of these has the higher priority, similarly to what we did in alkenes. So this top carbon has a CH3, whereas this the one on the bottom has a CH2. So this carbon has the higher priority because instead of having 3 hydrogens bonded to it, it only has 2 hydrogens and an extra carbon. And because carbon has a higher atomic weight, we give priority to this carbon. Using the same argument, on the other side of the double bond, this has the higher priority over this methyl group. So the alkene over here has priority groups on opposite sides of the double bond. So this is another E alkene. So we affix the configuration of the double bond before the name. And so this would be the complete name of the compound, including the stereochemical designation E. For this example, we have a much simpler benzene-based structure. So we have benzene and 1 substituent. So this time we'll follow the IUPAC guidelines and give benzene the priority over the alkene. This class of compound is an aromatic alkene, otherwise known as an arene. And the parent chain is benzene. There's no need to specify the double bonds on benzene because these double bonds have a property known as resonance. So this is just one of the 2 representations of benzene using the bond line structure. And it is understood that benzene has double bonds here, here, here. Or it could also be drawn here, here, and here. So it doesn't really matter. We don't need to specify the locants on the double bonds of benzene. Now this substituent is commonly known as an allyl group. An allyl group is just a propene fragment where the substituent is attached on the saturated portion or the CH2 portion. And we commonly call this in organic chemistry as the allyl or allylic position, whereas the positions on the double bond are called the vinylic positions. So we call this an allyl group, and so the name of this compound is allyl benzene. We can also name the allyl group in another way. In some textbooks, this is called the complex naming method for substituents. So if you can't remember allyl, we can name this using a more systematic approach. So we'll treat this substituent as if it were another parent chain, and we number the attached carbon, or the carbon that is attached to the parent chain, as 1. Because this is a 3-carbon fragment with a double bond at the 2 position, so this is prop 2-ene. And it is attached at the 1 position, so we write 1-il. And this is the more systematic way of naming the allyl fragment. Prop 2n 1-il. So the 2 refers to where the double bond is on the substituent relative to where the attached carbon is, or where this carbon is, the carbon attached to the parent chain. And the 1 refers to where on the chain the allyl group is attached. So it's attached on the 1 carbon. And so we can use this instead of the allyl name and write prop 2n 1-il benzene. This example is just allyl benzene with a new substituent over here. This NO2 group is called a nitro group. And as we said before, this is an allyl group. So we can easily name this arene as 1-allyl 4-nitro benzene. We write allyl first because it is written in alphabetical order, with A coming first before N. And we give allyl the lower locant by numbering it this way, because it's, again, the first substituent listed in the name, so we give it the lowest priority locant. Okay, if we number it the other way around, we'd still get the same set of locants, 1 and 4. So we give priority to allyl because it is first in the name. What about this compound? Now this compound still is an alkene. But for those of you who know a little bit more about functional groups, you'll notice that this carbon over here, this functional group is actually called an acetal functional group. And acetals are just named as if they were an alkene. And these groups over here are called methoxy groups. You have an oxygen attached to a methyl group. Therefore, the name is methoxy. If this had an ethyl group, this would be called ethoxy, and so on. So again, we can easily name this by identifying the parent chain, which is pent 1-ene. The substituents are 2 methoxys, or methoxy groups, and they are both positioned at the 4 position. Okay, 4,4-dimethoxy. So the name of this compound is 4,4-dimethoxy pent 1-ene. You can also name this as 4,4-dimethoxy 1-pentene. Moving on to the next example, we have this compound which has a triple bond. A CC triple bond belongs to a class of compounds known as alkynes. This compound is an alkyne. So single bonds alkanes, double bonds alkenes, triple bonds alkynes. Alkynes are named similarly to alkenes, so we have to find the longest chain containing the triple bond and give the lowest possible locant to the triple bond. So we number the chain this way, which gives a 1 locant to the triple bond, and because this is 9 carbons long, this is a non-1-ine or 1-nonine. We have a single chloro substituent at the 9th position. So the name of this compound is 9-chloro non-1-ine or 9-chloro 1-nonine. Either one is acceptable. However, again, the first one has the locant beside the ine, which is preferred in the IUPAC system. The nice thing about alkynes is that they don't exhibit any stereoisomerism. They're always flat or linear. So we don't need to determine its stereochemical designation. Now what if we have a double bond and a triple bond? This class of compounds would be called an enyne. So N referring to the double bond and ine referring to the triple bond. So the suffix of the parent chain would be enyne. Now for this first example, we'll think of the triple bond and the double bond as having equal priority. So all you have to do is get the lowest set of locants for both of these multiple bonds. So because this is a 10-carbon chain, the parent chain has a prefix dec. And since the compound is called an enyne, we specify the locant of the alkene first, 7, and then the alkane or alkyne, 1-ine. So dec 7 and 1-ine. This is the reason why IUPAC prefers that you put the number beside the thing that it is describing so that there is less ambiguity in the name. So this compound has no substituents, and therefore this is the final name of the compound. But this double bond also contains a stereoisomerism or exhibits stereoisomerism. So this is once again an E. So 7E, dec 7N 1-ine, or trans, dec 7N 1-ine. For the second example, we'll name it in a similar way. But if you notice, if you start numbering the chain, the alkyne, when numbered this way, gets a 2, and the alkene an 8 locant. But when numbered this way, the alkene gets a 2, and the alkyne gets an 8. So either way we number the chain, the set of locants are the same, 2 and 8. So how do we choose how to number it? Because the N is named first, we give the priority to the double bond. So for this second example, this is a dec 2N 8-ine. And once again, this is a Z alkene, so 2Z, dec 2N 8-ine, or trans dec 2N 8-ine. So again, if you have the same set of locants either way, you give priority to the substituent or the group that is named first in the name. Next up, we have another enyne. You might be tempted to start numbering the chain from over here where there is a substituent chloro on this side. But we have to remember that we have to give priority to either the triple bond or the double bond. So they must get the lowest possible locant. So for us to correctly name this compound, we have to start numbering from the other side. Numbering it this way so that the alkyne gets a 2 rather than this way, which gives the double bond a 3. So 2 is lower than 3, so we prioritize numbering it this way. So this is an enyne, and the parent chain is an oct 5 and 1 or 2 yne. There are two substituents, a 6-methyl and an 8-chloro. And there's a double bond, so we have to assign whether this double bond is an E or a Z configuration. So on this side of the double bond, the carbon takes priority over the hydrogen. And on this side, this CH2 group takes priority over the CH3 group. So because the priority groups are on the same side of the double bond, this is a Z alkene. So the correct name of this compound is Z. Okay, 5Z, 8-chloro, 6-methyl, oct 5, and 2 yne. Naming the chloro first because it's C over M for methyl, and Z referring to the 5th position double bond. That's it for this video. We've tackled alkenes, alkynes, and enynes, and in the next video we'll be tackling more complicated organic compounds containing new functional groups. I hope to see you then. For now, I'll see you later.